Hello, this is Tas, and this is second video of a series called GLSL Simple and Useful Tricks, where I'm trying to focus on very simple GLSL code that could do some effect that would be very difficult or even impossible to recreate without GLSL in Tops and Chops and TouchDesigner only. And also in this video series I'm explaining the GLSL code in much more details than in my other videos, so it's should be easy enough to follow for even for completely GLSL beginners. So this time the idea is to make a noise, because noise is very useful in generative design and generative art. But what I want to do is the noise where the period of a noise or a frequency of a noise, let me show you. Here is normal TouchDesigner noise stop, and the period of a noise affects how big or small scale of a noise is. And what I want to do is that took an input with black and white image, and for example for a white parts of the image have a very high frequency or low period noise, and for black low value of a period, the higher value of a period or lower frequency, because the frequency and the period is like an opposite of each other, and in some manuals and codes and noises it's called frequency, and another it's period, but that doesn't matter actually. So you could try to do the same with a second input of a noise stop, but it would be very difficult to create the input, so it would affect that both vertical and horizontal and looks like this. It's much easier to do with GLSL. And later you could use this noise for a whole range of everything, like a displacement, like just a nice coloring, or here is something a bit like a fluids, drops of fluid on the water or whatever. And here I could probably show you it a little more clear. So if my input is black, the noise period is high, and if my input is mostly white, the period is lower. Okay, that's enough, and let's do it from scratch. Here I have an empty network, and I need some input, and probably it would be a ramp. Ramp is very good input for this. And I want my input be 60 bits or 32 bits mono and fixed, not float but fixed. So it would change if you activate and press D. The fixed, the difference between fixed and float, the fixed is always between 0 and 1. And it's much better, so I could remap it to any values I want, because right now I could be sure that the minimum is 0 and the maximum is 1 always. So let's connect this to a GLSL, and let's also set some resolution a bit higher. All right, and I recommend you to use some external editor with syntax highlight. I'm using a Sublime Text, and here is default code for GLSL top. We don't need this. We would need this one, and maybe lower down this one. Okay, what we need. To the output we would need to have some noise. In TouchDesigner there is a, let's call it, let's create a new variable and call it a noise, and the noise would be a float noise. And in TouchDesigner there is two built-in functions called td Perlin noise and td simplex noise. I will use td Perlin noise as an input. And for this function you need to provide 2, 3 or 4 values, vector values. And for example, I could provide this vuvst, and what's vuvst is I could show you. Let me think. I could show you like this. For example, vuvst 1 1. Oops, what's going on? Yeah, and the pixel format, let's make it 32-bit float and make it 0. So what vuvst is a coordinate of an input, sorry, not of an input but on this node. And again, if I press D, vuvst goes from 0 to 1, and the red channel is horizontal and the green channel is vertical direction. So for every pixel the vuvst would be a little bit different between 0 and 1. And this is a good input for a noise, because we want, you could think about input of a noise like seed of a noise. And if every noise have one seed, for example, if I put a vector for 0.1, and for example here I would just duplicate the float noise in R, G and B channels, so it would be vec4, oops, noise on 3 channels, and the alpha would be, for example, 1, or you could make it 0 if you want. So if the all values of a noise of an input is the same, the output wouldn't look like noise. It would look all the same. But if I change it to vuvst, there is st means this is horizontal, it's vertical, so it's 2 values, and I declare that I want 4 values, so it would be vuvst, for example, 1 and 1. So now we have a different noise in our output, but it's way too big. So how we could make it smaller? First of all, you could change something about vuvst, because it goes from 0 to 1, and for example if you multiply it by 10, it have much more details. Because again, let me show it here as well. If I output color, so if I multiply it by 10, it's not going anymore from 0 to 1, but from 0 to 10. Okay. Oops. And by the way, this looks a bit awful, so I could do this absolutely the same but differently. This means vec-free noise, it means noise, noise, noise. So for R and G and B channels it would be noise. Or you could set the pixel format as a mono if you want. It doesn't matter. So this is one way. But another way would be, and we want to do it, is to use this input as a period of a noise. So let's uncomment the first line and let's call it period, and the period would be a text input texture. So now we could divide this to period. Oops, not period but period. And now we have a different noises, depends on the value. But what looks a little bit weird here is that it's stretched like a little bit diagonally. And this is because we don't have 0 on the center, but we have 0 here. So if we move the 0 to a center, now it looks much better. And probably you could set up this multiplication value whatever you want. I like to work with from -1 to 1. So it's VUVST multiplied by 2 and -1. Alright. So far so good. Let's animate the input so we could see it better, and probably I will use the circular noise, set it repeat as a mirror, maybe a period multiplied 2, and let's animate it. Apps times seconds. Maybe not so fast. Multiply by down 3. Alright. As you can see, it's a little bit too dark. And why it's too dark is because TD purely noise gives you back the value between -1 and 1. And for the color output, we probably want the value between 0 and 1. So we could multiply it by 2. Oops, multiplied by 0.5. So now it's from -0.5 to 0.5, and now add 0.5, and now it's between 0 and 1. Alright, and we don't need this anymore. It was just for demonstration. Oops, we don't need this anymore. Alright. So the next what I want to do is probably I would like to animate this noise, because if I stop this, everything is stuck, is constant. And if we took just a normal noise stop is the same, it's unanimated noise, and for animation you need to translate it or rotate or scale or do whatever you want. And for the simplicity I will do just a translation. I will call it utranslate, and it would be a vector 4, so it would contains 4 values. Why I call it utranslate, it's just a common practice, and U means uniform. And if you see this small letter U in the code, you know that it comes from this uniform page. Okay, and I need to declare it here. uniform vec4 u translate, right? And now I could just add this translate to this, because here I have vector 4 and here I also have vector 4, so everything is the same. And now if I animate this translation, the noise moves horizontally, the noise moves vertically, oops, it's too fast. The noise moves vertically or in 3D or in 4D. And it also means that you could animate it in general way, in most common way, apps times seconds, but you could also animate it, goes it for a circle, for example, here to make it perfect loops. And by the way, I have a tutorial about making perfect loops, so you could see it there. But right now, let's leave it here. And another detail about the period. I could also divide my translation to the period. But that would mean that I would need to multiply much lower, something like this. And it's not so easy to work with this input, so I prefer to not to deform the translation from my input, but to use the translation without any multiplication. But you could do whatever you want. Alright, and also what I want to do is I want to have the possibility to remap the range of input, because right now it's my values changes from, so my period changes from 0 to 1, and maybe I want to make it a little bit different, like we have like we could do in the math top. You could say the range not from 0 to 1 and change it from 0.2 to 0.8, for example. But we could do the same in GLSL code, just for education purposes. So let's call it remap, and we will need two values. This would be a minimum, this would be a maximum, and what I like to do is to put something ridiculous like 99999 on the values that I didn't use. So if I come back to this file like a couple months later, I would immediately see that this uniform holds only two values. But of course I could see it here as well. Uniform vec2 remap. And for remapping, I googled Stack Overflow how to do it, and here is the best answer. And for remapping, I could use this formula. And by the way, I could here is my main function, but I could separate anything I want in a separate function. I could remap it here, but I could make another function. And let me make so float, I'll call function remap, and as an input it would need float value. So it would need value, and it will remap it. So here's my formula. I could comment this. And as a return, So this function will return, it should return a new value, like so. But what we know is this the input value is, which is with index 1, is between 1 and 0. So we could change it from 1 to 0. So it would be divided by 1, which means nothing. And minus 0, it also doesn't need so. So right now the formula is much simpler. So we need two values, and we have it, because our value for remapping, the lowest value would be remap x, and the high would be remap y, and here we also need remap x, and here we have it, and we return this thing. Okay, and now we could remap our period. By the way, we have period as a vector 4, but actually we have only one channel, so we could make it float. And since we texture always think that we input in RGBA channels, so we need to declare that we only need R channel. And now it's float, and let's period equals remap, and as an input we gives a period. Alright, and because right now the values is 1 1, the noise is the same, but let's me remake it, for example, for 0.2 to check to 0.8, and that's it. So we can now manipulate our period here as well. And of course this is a very useful function that you could use in many other situations. And another thing that comes to my mind is that we could separate this parallel function also in, so we could took this and make a separate function for this. Why is this? Let me first do it. Float, let me call it parallel, and it will need as input. What does it need for input? Yeah, let's use this for input, or the whole, yeah. And as input we want vec4 chords. Let's call it chords. And let's copy paste it almost. Return to deep parallel noise. Let me think how it's better to do. Let me check how I did it here. Here I'm using only period. I don't know, you could do it in many different ways. Let me do it yeah, let me just do it like this. Chords, and here now I would call the function called parallel. and it should return the same. Yeah, it's returned the same. And why I did this is because we also have, for example, TD simplex noise, or you could Google on GitHub or on Shaditor or somewhere else how to make the value noise, the fractal brown motion noise, or fractal noise, or Varley noise, or any different noise. So you could, let me show it with a simplex because it's super simple. I don't need much change. So now I could, instead of Perlin, call another function and have another noise. And also I could here make another, or somewhere in UI, in interface, make a list and to choose which kind of noise do I want to have, the Perlin or a simplex, and make here a if-else statement. And if I choose the Perlin, then run this function, and if I choose the simplex, run simplex function. But I wouldn't do it right now because it's not so important. Alright, so that's probably it. Let me see what I have here in my pre-made one. Yeah, it's almost looks the same. So probably that's it for the main part. And now you could use this noise in different situations. Let me show you what I did. For example, I could use the regular noise stop as an input, connect it to this noise, maybe run it one more time, because here I have not so good thing, because here, let me pause. Here I have completely black spot, so on this spot the value, the period of a noise is the same, and it looks not very good. So I run another round of the same code with a little bit different period. By the way, you could also do it. Let me see if I increase the number of paces. I could do it like this, but if I increase the number of paces, it will run this code over and over again, but with the same values. And if you want different values, you just connect to the same code. And here, if you have a nice color ramp, you could do lookup. Here is just a simple displacement that I'm using it, a little bit rescale it to fit the grid, and use it as a normal map and a hide map. Super simple. And of course you could use the noise, you could try to use this kind of noise in many different other scenarios. And maybe a couple more ideas is in noise top. It would be much harder to realize harmonics because it will require a lot of code. But you could, if you open palette and check a generator and check a noise, all of noises here, it's made in GLSL, and you could check how it's made, but it's pretty hardcore. Yeah, as you could see, it's a little bit more code than we have here. We have maybe 25, a little bit more than 25, but yeah, much simpler code. But seed, we could implement seed. Actually, if we just translate it to the one, it's almost like could act as a different seed. But you could add another, but you could add another uniform called seed and just add it here somewhere. If you want to change the amplitude of a noise, of course you could do it the same with another input, but in my opinion what amplitude do is multiplication noise with some constant or remapping noise, and it's the same with offset, and it's much simpler to do with level or with the math, because right now if I could decrease noise, I could offset it, or I could change the amplitude by multiplying it. So I don't see any reason to do it in code unless you run into FPS issues, because GLSL works faster than making a lot of compositing. So if you want, you could do this in the code. And exponent could be done with a level. With a level, with manipulating the contrast and the gamma maybe, you could achieve the result similar to what exponent does. But if you want, of course, you could also implement this in a code itself. What else do we have here? Monochrome, non-monochrome noise. I believe this is just add a noise on different, so it creates 3 different noises and distribute it between channels. So if I make 3 noises and change the seed a little bit, I could also make non-monochrome noise. For example, reorder, second input, third input, first input is red, second input is green, and third input is blue. And you could do the same with alpha if you want. So again, this is up to you. You could do all of this in code by just copy pasting. Like for example, you could create here a noise red, and for the noise green add some seed here, and then instead of vec3 noise you would say noise red. Okay, let me do it. Yeah, why not? Let me do it because it could be super fast. And by the way, let me just copy paste it here. Why not? What I need is float noise equals what's going on? We don't need this. What's going on? Cast is not allowed. 33. Yeah. Right now I don't have noise here. So noise R, copy paste, R, G, B, 1 plus, 2 plus, and now I would want noise R, noise RG, B, and here we have it, the non-monochrome noise. But again, it's up to you. You could use compositing if you not run into FPS issues. And probably that's it for today. If you have any questions, leave it in the comments. if you like this tutorial and want to support me, you could do this on Patreon, and on Patreon I would also upload this example in case if you curious how to make a displacement, or if you want this palette tool, which is super simple GLSL code from Inigo Quiles. So that's it. Thank you, goodbye, and see you next time.